What if I told you you've already been traveling in time your entire life? That every second that passes, every breath you take, every memory you recall, and every dream you project forward are all proof that you are, right now, a time traveler. It sounds shocking, almost unbelievable, doesn't it? When you think of time travel, your mind probably races toward flashing machines, whirring gears, or cinematic moments of stepping into a glowing portal and reappearing centuries earlier. Or later. That's the science fiction version, the one you've grown up watching in movies, reading in novels, or imagining late at night when your thoughts wander into the impossible. But pause for a moment. Look at your own life. Look at the clock. Yesterday is gone forever, and tomorrow has not yet arrived. Yet here you are, continuously moving forward at the steady, unstoppable pace of 1 second per second. You are surfing on the river of time, carried downstream whether you want to be or not. That's the first emotional twist in our story. Time travel is not just a theory or a dream or a wild piece of fiction. It is happening to you right now as you listen, and maybe deep down you felt it, that strange pull of nostalgia when you close your eyes and suddenly you're 5 years old again, running barefoot in the summer sun, or the aching anticipation when you imagine your future self, older, wiser, maybe even walking the streets of some distant city you've not yet seen. Those aren't just emotions, they are tiny forms of mental time travel. Your brain itself is a time machine. It takes you backward into vivid memory. It throws you forward into elaborate imagination. And while the body stays here, anchored in the present, your mind refuses to obey the limits of the clock. But of course, what we really wonder is something far bigger. Can we bend time itself? Can we leap decades in an instant? Can we go back to fix a mistake or jump forward to witness wonders our great great grandchildren will one day see? Can we, in the truest, most literal sense, really travel in time? That question has haunted humanity for as long as we've had stories to tell. Think about it. The longing for time travel is not born in science. It's born in the heart. It's the desire to see a lost loved one again, to stop a tragedy before it begins, to return to a moment of happiness and never let it slip away, or to skip past pain and reach the brighter tomorrow. The fantasy of time travel has always been an emotional one first, and yet, science has slowly caught up with the dream. For centuries, time seemed fixed and absolute, ticking away like the gears of some cosmic clock. But then cracks began to appear in our understanding. Mystics imagined time as a wheel, a cycle that turns forever. Ancient philosophers wondered if fate was already written. And then, much later, brilliant minds like Isaac Newton, Albert Einstein, and Stephen Hawking began to dismantle the illusion of time as something rigid and simple. Today, you live in a world where scientists can prove that time flows differently depending on where you are, how fast you move, and how much gravity surrounds you. That's not science fiction. That's reality. And it means that the door to time travel, real time travel, might not be as firmly shut as you once believed. So let me guide you on a journey. A journey not through space, but through the history of time itself. Together, we'll wander across ancient myths and modern laboratories, across black holes and wormholes, across paradoxes and possibilities. We'll explore why your GPS works only because satellites are literally experiencing time differently. We'll step into Einstein's vision of clocks ticking at different speeds in different parts of the universe. And we'll dive into the very human side of it all, why the idea of bending time stirs something so deep inside your soul. But before we leap too far, I want you to sit with a simple truth. Every second that passes, you are moving into the future. You can't stop it. You can't slow it down, and you certainly can't reverse it. Yet this gentle, unstoppable current connects you to every living thing on Earth, and perhaps to every consciousness that has ever looked at the night sky and wondered, what if we could escape the flow? It is here, at this delicate threshold between science and longing, that our story begins. Because the question is not whether time travel is possible. The real question is, what kind of time travel are we really searching for? The kind that science can measure, or the kind that our hearts silently yearn for in the middle of the night? And as we continue, you'll see that the two may not be so different after all. Now, let's take a step back, far back into the ancient past, into the first myths and legends where humanity dared to imagine what it would mean to slip the chains of time itself. Close your eyes for a moment and let your mind drift. Where do you go? Maybe you find yourself walking the halls of your childhood school. The smell of chalk and old books thick in the air. Maybe you see a younger version of yourself standing nervously on the first day of college. Or perhaps you leap forward, imagining a day that hasn't yet happened when you finally accomplish a dream that's still waiting in the distance. This is the first kind of time travel you've always had access to, the travel of the mind. You don't need machines, equations, or cosmic forces. All you need is memory and imagination. And though it may not sound as dramatic as stepping into a time machine, it's something so universal, so human, that you almost forget how miraculous it is. Think about memory. What is it really? It's not just a record, it's a doorway. The moment you recall the sound of your grandmother's laughter, you are not here anymore. For just a split second, you've returned to a different era, a different you. Your heart swells, your skin tingles, and the past becomes almost tangible again. Isn't that a kind of travel? You've bent time inside your own mind, pulling yourself into a moment that no longer exists, yet feels as if it never left. And then there's imagination, the other side of your mental time machine. When you picture your future self, when you rehearse conversations that haven't yet happened, when you dream of what life might look like in 10 or 20 years, you are projecting forward. You are testing possibilities, shaping paths, walking through invisible doors. This forward leap is so natural that you hardly notice you're doing it. But here's the fascinating twist. Neuroscience tells us that the same regions of your brain that recall the past are also responsible for imagining the future. In other words, to look forward, you must look backward first. Your mind recycles fragments of memory, rearranges them, and builds imagined futures out of them. You cannot dream of tomorrow without carrying yesterday along with you. That makes your brain not just a time traveler, but also a time architect, constantly building bridges between what has been and what might be. And yet, even as this inner time travel feels rich and vivid, it comes with limits. The past you remember isn't a perfect recording. It's fragile, colored by emotion, altered each time you recall it. Psychologists remind us that memory is not a photograph. It's a story we tell ourselves again and again, each time slightly different. Which means, in a strange way, every trip back to the past is both real and not real at the same time. You're revisiting, but you're also rewriting. The same is true when you leap forward in your mind. The future you imagine will almost never unfold exactly as you picture it. But that doesn't make it useless. On the contrary, it may be the most powerful tool you have. Athletes visualize before competition. Entrepreneurs picture their goals before achieving them. Scientists dream of discoveries before they make them. Imagination is practice, rehearsal, and prophecy all at once. So here's the emotional truth. You've been time traveling since the day you were born. You've gone backward with memory, forward with imagination, and sometimes even both at once. When you compare your present self to who you were years ago, you're standing on a bridge that spans time. And every time you look at an old photograph or listen to a song that belonged to another chapter of your life, you are stepping through the folds of your own timeline. But if this is true, why does it still feel incomplete? Why do we still yearn for something more? Why do we still hunger for the possibility of machines, portals, and cosmic tricks that could carry us beyond the limits of mind alone? The answer lies in our longing for permanence. Memory fades. Imagination is uncertain. But the human heart craves something solid, something that would let us truly go back, truly relive, truly rewrite. We don't just want to feel the past, we want to touch it. We don't just want to dream of the future, we want to see it with our own eyes. That yearning is what drives the myths, the legends, and the science. And so, before science ever gave us equations, humanity created stories. Stories of gods who could reverse time, heroes who could leap into the future, kings who slept for centuries and awoke in a world transformed. These myths weren't just fantasies, they were reflections of the deepest desire inside us to escape the cage of the present moment. Which brings us to the next step of our journey. If you and I have always traveled in time inside our minds, then what about our ancestors? Long before Einstein or Hawking, before physics and laboratories, how did ancient civilizations explain the dream of breaking free from time's flow? To answer that, we must step backward, far backward, into the cradle of myth and legend, to the worlds where time was not measured by the atomic clocks, but by the rising sun, the harvest moon, and the cycles of the stars. It is there, in the stories told around fires under starlit skies, that the first seeds of time travel were planted in human imagination, and those stories will surprise you. Long before scientists measured time with atomic clocks, humanity told stories. Around flickering campfires, beneath the endless canvas of stars, people searched for meaning in the flow of days and nights. They noticed the seasons returning, the moon waxing and waning, the cycles of life and death, and they wondered, was time a straight path or was it a circle? Could it bend? Could it be escaped? And so in myth after myth, in culture after culture, the seeds of time travel appeared. Take the ancient Hindus. In their vast epics, time was never rigid. It was fluid, layered, divine. One story tells of King Kakudmi, who traveled to the realm of Brahma, the creator god. What felt like only minutes in Brahma's world turned out to be thousands of years on Earth. By the time Kakudmi returned, entire generations had vanished, and his kingdom was nothing but memory. This tale, told thousands of years ago, mirrors exactly what modern science calls time dilation, the idea that time can move differently in different places. How could storytellers have imagined something so close to Einstein's relativity long before he was born? The Greeks, too, have dreamed of bending time. You may have heard of the tale of Endymion, the beautiful shepherd whom the moon goddess Selene loved. According to legend, Zeus granted Endymion eternal sleep, allowing him to remain forever young as the world aged around him. Isn't that a form of time travel too? Stepping out of the rushing river of years while everyone else is carried downstream? In another story, the hero Odysseus encounters strange islands where time flows differently, where days blur into years. These myths were not just entertainment. They were humanity's first explorations of what it would mean to be unchained from ordinary time. Across the world in Japan, you find the story of Urashima Taro, a fisherman who rescued a turtle and was rewarded with a journey to an undersea palace. He spent what felt like a few blissful days there, but when he returned to the surface, centuries had passed and his entire village was gone. This story echoes across cultures, a place where time runs slower, where stepping away for a moment means losing everything you once knew. It's both wondrous and tragic, the emotional core of time travel itself. The Norse people also imagined time as flexible, cyclical, and destined for collapse and rebirth. Ragnarok, the end of the world, was not an end at all. It was a reset, a looping of time into another cycle. To them, time was not an arrow pointing endlessly forward, but a wheel turning again and again. Even in the Abrahamic traditions, you find whispers of time bending. The biblical story of Joshua commanding the sun to stand still is essentially a pause in the flow of time. In Islamic tradition, there is the tale of the Prophet Muhammad's night journey, the Isra and Miraj, in which he travels vast distances, experiences divine visions, and returns in the span of a single night, time stretching and compressing in ways that defy ordinary understanding. What do all these stories reveal? They tell us that the dream of time travel is not modern. It is ancient, universal, and deeply human. Whether in India, Greece, Japan, or Scandinavia, people longed for the same things: to hold on to what was slipping away, to leap into what had not yet arrived, to step outside of the fragile present. And notice the pattern. Almost every myth ties time travel to emotion. A king loses his people, a fisherman loses his home, a goddess clings to her lover. These aren't just tales of bending physics, they are tales of bending the heart. The tragedy of returning to find the world changed, the people gone, the moment lost forever, that's what makes time travel both terrifying and beautiful. But myths didn't stop at storytelling. They shaped how entire civilizations viewed life and death. For the Hindus, time was vast, spanning unimaginable cycles called kalpas, in which universes were born and destroyed again and again. For the Greeks, time was personified in two forms: chronos, the relentless ticking of the clock, and kairos, the opportune moment, the right time. Even today, you live between these two, the unstoppable march of seconds and the fleeting, precious windows that define your life. So when you think of time travel, remember this. Before science gave us equations, humanity gave us stories. And those stories were not just entertainment, they were survival. They gave comfort in the face of death, meaning in the face of change, and hope in the face of uncertainty. They let people believe that maybe, just maybe, time was not a prison but a mystery, one that could be softened, stretched, even transcended. And perhaps that's why, thousands of years later, when Einstein shattered the old view of time, it felt both revolutionary and strangely familiar. It was as if science had finally caught up with what storytellers had always suspected: that time is not simple, not equal, not absolute. So, as we leave the flickering firelight of myth and step into the bright laboratories of modern science, you'll see that the dreams of the ancients were not so far from the truths we've discovered. Because the universe, it turns out, does not tick like a perfect clock at all. It bends, it stretches, it twists. And it is here, with Newton and later Einstein, that the story of time takes a shocking turn. For thousands of years, people measured time in the simplest ways possible: the rising sun, the setting moon, the turning seasons. To them, time felt steady and universal, like a drumbeat that never faltered. But then, in the 17th century, one man gave time a form so rigid, so absolute, that it ruled science for centuries. That man was Isaac Newton. Newton imagined time as a vast, invisible stage. The actors, planets, stars, apples falling from trees, moved across this stage, but the stage itself never changed. Time, in Newton's world, ticked steadily forward at the same rate for everyone, everywhere. Whether you were a farmer in England, a sailor on the open sea, or a planet orbiting the sun, you were all marching to the same universal clock. This idea fit beautifully with Newton's mechanics. His laws of motion and gravity depended on time flowing evenly, like sand slipping through an hourglass. And for centuries, scientists accepted it. Time was absolute, simple, unshakable. But cracks began to appear. By the 19th century, physicists studying light noticed strange inconsistencies. Light, it seemed, always moved at the same speed, no matter how fast you were moving toward or away from it. This was deeply unsettling. According to Newton's framework, speeds should simply add or subtract. If you throw a ball while running, its speed is the sum of both motions. But light didn't follow this rule. No matter what, it stubbornly raced through the universe at 299,792 kilometers per second. Something didn't add up. Enter Albert Einstein. In 1905, at just 26 years old, he shattered the old stage of Newton's universe and built something entirely new: the theory of relativity. Einstein's genius was simple yet profound. If the speed of light never changes, then it must be time and space themselves that do. Imagine two observers, one standing still, another speeding in a spaceship. To keep light moving at the same speed, for both of them, time itself must stretch or compress. The faster you go, the slower your clock ticks compared to someone standing still. Suddenly, time was no longer universal, it was relative. Think about the emotional weight of that. For centuries, humans believed we were all sharing the same river of time. Einstein revealed that we're not. We each carry our own river, flowing at its own pace, shaped by our motion and even by the gravity around us. And Einstein didn't stop there. In 1915, he expanded his ideas into the general theory of relativity, showing that gravity itself could warp time. Massive objects like planets and stars don't just pull on space, they slow down time itself. If you lived near a black hole, for example, your seconds would stretch longer than those of someone far away. You'd be aging slower while the rest of the universe rushed ahead. At first, these ideas sounded outrageous. How could time bend? How could clocks disagree? But as the decades passed, experiments began to confirm them. Scientists flew atomic clocks on airplanes and proved they tick slower than identical clocks on the ground. Astronauts on the International Space Station age just a little bit less than their twins on Earth. GPS satellites must correct their time daily because both their speed and the weaker pull of Earth's gravity make their clocks drift. Without Einstein's corrections, your navigation apps would be useless within minutes. So here's the shocking truth. Time travel is not just possible, it's already happening. Every astronaut, every satellite, every beam of light streaking through the cosmos is proof. Time bends, time stretches, time flows differently in different places. And this realization forces us to ask, if time can already be bent, stretched, and slowed, how far can we take it? Could we push it to extremes? Could we ride it like a wave into the distant future? To see just how real this is, you don't need to imagine futuristic machines. You only need to look at the skies. Because out there, in the vacuum of space, time behaves in ways that feel like science fiction, but are measurable, repeatable, undeniable. But before we leap into cosmic black holes and near light speed journeys, let's linger here a little longer. Think about what Newton and Einstein truly gave us. Newton gave us certainty, a universe where time is steady, predictable, a constant companion. Einstein gave us wonder, a universe where time is alive, flexible, and deeply personal. And this shift isn't just scientific, it's emotional. Under Newton, you were trapped in a rigid clock, powerless. Under Einstein, you're a traveler, moving at your own unique pace through the cosmos. Every heartbeat, every step, every orbit is its own timeline. It's humbling, isn't it? To know that even now, as you sit and listen, your time is not flowing in exactly the same way as mine. We are all time travelers, drifting through slightly different rivers shaped by speed and gravity. And though we don't notice it in daily life, the differences are real, measurable down to the billionth of a second. This is where the ancient dream begins to merge with scientific truth. Time is not absolute. Time can be bent. Time travel, at least into the future, is not only possible, it's inevitable. The only question left is, how far can we go? And to answer that, we must leave Earth behind and step into the experiments and experiences that show us what time travel looks like, not in theory, but in practice. If time really bends and stretches, you don't need to travel to a black hole to prove it. You can see it right now on Earth, in orbit, and even in the pocket of your hand. Let's begin with a story. In 1971, two scientists, Joseph Hoffele and Richard Keating, carried 4 atomic clocks aboard commercial airplanes. They flew them around the world, once eastward and once westward. When they returned and compared the clocks with identical ones left on the ground, the results were stunning. The clocks on the planes were different. Time had ticked at a slightly different pace depending on the direction of travel and the speed of the aircraft. This wasn't a glitch. It was Einstein's relativity made real. Time dilation, proven by experiment. That was over 50 years ago. Today, the evidence has only grown stronger. Consider the astronauts aboard the International Space Station. They orbit Earth at nearly 28,000 kilometers per hour. At that speed, time slows down for them compared to us on the surface. The difference is tiny, just fractions of a second over 6 months, but it's real. And it means that astronauts return home ever so slightly younger than their identical twins on Earth. In fact, NASA once conducted a remarkable experiment called the Twin Study. Astronaut Scott Kelly spent nearly a year aboard the ISS while his identical twin brother, Mark Kelly, remained on Earth. Scientists compared their bodies, their cells, even their genes. And when Scott returned, the results showed what relativity predicts. He had aged just a little less than his brother. For the first time in history, the famous twin paradox wasn't just a thought experiment, it was human reality. But you don't have to leave the planet to see relativity in action. Every time you use your phone's GPS, you are relying on satellites orbiting Earth. Those satellites carry precise atomic clocks. But here's the twist. Because they are moving quickly, their time runs slower due to their speed. At the same time, because they are farther from Earth's gravity, their time runs faster compared to clocks on the ground. These two effects, opposite in direction, don't cancel out perfectly. They add up to a total drift of about 38 microseconds per day. Now, 38 microseconds may sound tiny, but if engineers didn't correct for it, GPS would be off by kilometers within hours. Think about that for a second. Every time you check Google Maps, call a ride, or navigate through traffic, your phone is compensating for time dilation. You are literally using proof of time travel every single day without even realizing it. This is where the story becomes emotional. Time travel is not science fiction. It's not some distant dream. It's woven into your daily life. Satellites age differently. Astronauts age differently. Even the ticking of clocks on airplanes shifts depending on speed and gravity. We live in a world where time refuses to stay equal for everyone. And here's the mind-bending part. These differences, small as they seem, can be scaled. If moving at 28,000 kilometers per hour slows time by fractions of a second, what would happen if we traveled at 99% the speed of light? Suddenly, those fractions become years, decades, even centuries. You could leave Earth, journey at near light speeds, and return to find that while you experienced only a few years, hundreds had passed back home. In fact, we've already seen glimpses of this in nature. High-energy particles called muons constantly shower Earth from cosmic rays. On paper, they should decay almost instantly, yet many reach the ground. Why? Because they are traveling so fast that time dilates for them. In their own frame of reference, their brief lives tick normally. But to us, watching from Earth, their clocks are stretched, allowing them to survive long enough to be detected. These subatomic travelers are living proof that speed bends time in dramatic ways. So when you think of time travel, don't imagine gears and glowing portals. Imagine satellites above your head, astronauts circling Earth, and cosmic particles racing through the atmosphere. They are all whispers of the same truth. The universe already allows time travel, not the wild leaps of movies, perhaps, but the slow, steady bending of time itself. And here's the emotional twist. This isn't just science. It's personal. Every one of us is already moving through slightly different timelines. Time is not a single river we all share. It is a network of streams, each flowing just a little differently depending on where we are and how we move. The seconds that shape your life are not quite the same as the seconds that shape someone else's. That means, in a very real way, no two people ever experience time in exactly the same way. And isn't that strangely beautiful? The life you are living, the minutes you are breathing in right now, are uniquely yours. Your timeline belongs only to you. But as incredible as this is, we've only scratched the surface. Because if speed and gravity can bend time, what happens when we push them to extremes? What happens if you approach the edge of a black hole where gravity is so strong it bends light itself? Could you step outside the flow of time entirely? Could you stand still while the rest of the universe rushes ahead? That's the question waiting for us next. If time can bend, slow down, and stretch, you might be wondering, why not simply push faster? Why not build a ship, accelerate to unimaginable speeds, and leap centuries into the future? The answer lies in a boundary so absolute, so fundamental, that it defines the structure of reality itself, the speed of light. Let's pause and picture this. Light doesn't crawl or stumble, it races. It moves at 299,792 kilometers per second. In just 1 second, it can circle Earth more than 7 times. For generations, scientists dreamed of chasing it, of catching it, of maybe even outrunning it. But then came Einstein, and with his theory of relativity, the rules changed forever. Einstein showed that no matter how fast you move, no matter how hard you accelerate, light will always stay ahead. If you run toward it, it doesn't look closer. If you race beside it, it doesn't slow down. Light doesn't adjust for you, you adjust for it. Space and time themselves bend and warp to ensure that light's speed remains constant, universal, untouchable. And here's the emotional catch. This isn't just a number. It's the skeleton of reality. It means there is a cosmic speed limit, a wall you cannot cross. You, me, every particle, every star, all are bound by this law. The universe has drawn a line in the sand, and that line is the speed of light. But what happens as you approach that line? This is where things become almost mystical. As you accelerate closer to light speed, strange things happen. Your mass increases, not in the sense of growing bigger, but in the sense of resistance. It becomes harder and harder to push you faster. Every burst of energy you add buys you a smaller and smaller increase in speed. By the time you near the speed of light, your mass would appear infinite. And to push infinite mass any further, that would take infinite energy, a price the universe does not allow you to pay. And time? Time behaves like liquid glass. The faster you go, the slower it flows. At 90% of the speed of light, clocks aboard your ship would tick about twice as slowly as clocks on Earth. At 99%, your time shrinks even further. Push it to 99.9%, and you could cross an entire galaxy in what feels like a lifetime, while millions of years pass outside. This is where science meets wonder. You don't need a portal or a machine or a spell. If you could build a ship fast enough, you would step into the future. Not by choice, but by nature's design. Your seconds would stretch into hours, your hours into years, while the outside universe races ahead. You would arrive at tomorrow while Earth has aged into centuries. That is not fantasy, that is physics, and yet the wall remains. You can never cross the speed of light, you can never catch it. You can only approach, and in approaching, you begin to dance with time itself. Think about what this means for human dreams. If one day, far in the future, we build engines that push us to 99.9% of light speed, we could leave Earth, travel for a few decades, and return to find millennia have passed. Imagine setting out from home, waving goodbye to the world you know, and returning to a planet that no longer remembers your name. The mountains would be worn, the oceans reshaped, civilizations risen and fallen. You would have traveled into the future, but the cost would be everything you once called familiar. And here lies the emotional paradox of time travel by speed. It is possible, science confirms it, but it is one way. A ticket forward with no return. You cannot slow time for yourself and then rewind it later. Once you step into that rushing river, you cannot climb back upstream. This is why light is not only a speed, it is a storyteller. It defines the boundary of our possible futures. It whispers that time travel is real, but not free. That every dream of outrunning tomorrow comes with sacrifice. But humanity is never content with limits. Even as we accept that light's speed is untouchable, we ask, could there be a loophole? Could there be hidden doors, shortcuts through space-time that let us cheat the rules? Could there be paths not around the wall, but through it? This is where the next chapter begins, a chapter of wormholes, cosmic tunnels, and the bending of space itself. Because if you cannot outrun light, perhaps you can reshape the very stage upon which light moves. And so the cosmic speed limit is not the end of the story. It is the challenge, the obstacle, the cliff at the edge of the map. It forces us to look deeper, to imagine stranger, to ask questions that feel more like dreams than equations. Because somewhere beyond that wall may lie the ultimate answer, the way not just to stretch time, but to fold it. And that is where we must go next. You've now seen the limits of speed. You know that light is a wall you cannot climb. But here's where the universe teases us with something even stranger, but something that sounds like it was pulled from the pages of science fiction. Imagine for a moment that you don't have to outrun light at all. Instead, what if you could take a shortcut? What if space and time themselves folded like a sheet of paper and you could step through a tunnel from one side to the other? That tunnel has a name, the wormhole. The concept was born from the mathematics of Einstein's general relativity. Back in 1935, Einstein and his colleague Nathan Rosen studied the equations that describe spacetime and discovered something unusual. The math suggested that two distant points could be connected by a bridge, a passage carved into the very geometry of the universe. This became known as the Einstein-Rosen bridge, or what we now call a wormhole. Picture space-time as a flat sheet. If you wanted to travel from one corner of the sheet to another, you would normally crawl along the surface. It could take forever, but if you fold the sheet, suddenly those two corners touch. A wormhole is like punching a hole straight through, creating a direct link between faraway regions of space, or even different points in time. It sounds magical, it sounds impossible, but the beauty is that the math works. Wormholes are not forbidden by physics. They sit quietly inside Einstein's equations, waiting like hidden doorways. The challenge, of course, is whether nature actually builds them. Now imagine the emotional weight of what this means. Instead of aging centuries on a near-light journey, you could step into a wormhole and emerge across the galaxy in an instant. The stars that would otherwise take generations to reach could be just one breath away. The past and the future might not be unreachable. They might be a single step through the right tunnel. But wormholes, if they exist, are tricky creatures. First, they are unstable. A natural wormhole would collapse almost instantly, snapping shut before anything could pass through. To hold one open, you would need something exotic, matter with negative energy density, something that pushes instead of pulls. Theoretical physicists call it exotic matter. We have never found it in usable amounts, though tiny glimpses of similar effects appear in quantum experiments. Second, there's the danger of paradoxes. A wormhole doesn't just connect space, it can connect time. If you move one end of a wormhole at near light speed and then bring it back, relativity tells us that the two mouths will no longer agree on time. In essence, step through one, and you could emerge before you even entered. That's time travel, raw and terrifying. Let's pause here. Imagine standing before such a tunnel. You reach out your hand. You know that on the other side might be your own yesterday or centuries ahead. You could meet your younger self. You could witness your descendants. You could change history or watch helplessly as it changes itself. This is where the emotional paradox deepens. We long for wormholes because they offer the ultimate freedom. But freedom comes with danger. If even a single wormhole allowed travel to the past, paradoxes explode. Could you prevent your own birth? Could you erase the invention of the wormhole itself? Physicist Stephen Hawking once suggested that perhaps the universe protects itself with what he called chronology protection. In his playful words, maybe time travel to the past is forbidden because otherwise the universe would be too messy. Still, the dream persists. Wormholes ignite our imagination more than any spaceship or rocket ever could. They are the ultimate metaphor for escape, not just from distance, but from destiny. They whisper that maybe we are not prisoners of time after all, but explorers waiting for the right key. Scientists continue to search. We scan the sky for signs of gravitational oddities, for cosmic strings, for phenomena that might hint at hidden tunnels. We test equations, play with simulations, and imagine technologies powered by fields we cannot yet control. Each step brings us closer, not just to understanding wormholes, but to understanding our relationship with time itself. Because here's the quiet truth. Whether or not wormholes exist, they represent our deepest desire. We don't simply want to move faster. We want to escape the boundaries of what we know. We want to fold the page, not just turn it. We want to write new endings to old stories. And so wormholes occupy a unique space in our journey. They are science, yes. They are math, yes. But more than that, they are poetry written into the fabric of the universe. They remind us that the laws of reality are not cages, they are mysteries. Mysteries that may hold doors we have not yet dared to open. But if wormholes tempt us with visions of shortcuts, they also confront us with a haunting question. What happens if we actually step through? What if the universe does allow us to visit the past? What if you could return to that single moment you regret most and change it? That is the paradox we must face next. The paradox of going backward in time. Section 7 complete, 1070 words. Would you like me to move into Section 8? Can we go backward? Style. Section 8. Can we go backward? So far, you've seen how time can stretch, how speed and gravity can fling you forward, and how wormholes tempt us with shortcuts. But let's stop pretending. Let's address the question you've been quietly holding inside. Can we go back? Forward is safe. Forward is natural. Forward is what you're already doing at this very second. But backward, that's where the human heart aches. We don't dream of rockets to the future. We dream of turning around, of one more conversation with someone gone, of one more chance to make it right, of undoing the choice that still wakes you at night. This is why the question cuts so deeply. If time travel is real, if physics allows even a whisper of it, then the first thing you want is not to leap ahead. It's to return. But the universe has a way of making the past dangerous. Let's take a simple thought experiment. Suppose you step through a wormhole and emerge 50 years earlier. You walk into a house you know well. You see your younger self, perhaps a child, sitting at a table. What do? Do you say hello? Do you warn them about mistakes they haven't made yet? Do you try to save them from heartbreaks, from accidents, from paths you wish you could erase? Here's the paradox. If you succeed, if you truly change their future, then the version of you who entered the wormhole never existed. You would erase yourself with your own actions. This is the famous grandfather paradox. If you traveled to the past and prevented your grandfather from meeting your grandmother, you would never be born. But if you were never born, how did you travel back in the first place? It's a loop that collapses under its own weight. The emotional punch is this: the past is not just events, it is your foundation. To change it is to change yourself and perhaps erase yourself entirely. Physicists wrestle with this puzzle. Some suggest that paradoxes prove backward time travel is impossible. Stephen Hawking, with his chronology protection hypothesis, argued that the laws of physics themselves prevent such loops from forming. In other words, the universe defends its own timeline. But others suggest another way out. Maybe you can go back, but you cannot change what already happened. This is called the Novikov self-consistency principle. It means any trip to the past would already be woven into history. If you tried to stop your grandfather from meeting your grandmother, something would interfere. You'd drop the gun, or he'd miss the train, or fate itself would conspire to preserve the timeline. You would not be free, only a participant in the story already written. This explanation is logical, but haunting. It means even if you could step into yesterday, you would not be able to rewrite your regrets. You could only witness them unfold, powerless to change the outcome. You could hug someone, but you would lose them again, inevitably, because that's what history says must happen. And then there's a third possibility. Perhaps every action spawns a new branch of reality. This is the multiverse idea. In this view, you could travel back, make a change, and instead of erasing yourself, you would create a new timeline. In one universe, you never left. In another, you changed everything. It sounds hopeful, comforting, even. Imagine rescuing someone in one branch of time while still existing in another. Imagine correcting mistakes in a new reality. But here's the emotional sting. That timeline is not your own. You wouldn't be fixing your past. You'd be birthing an entirely new world, one you might never fully belong to. So the answer to backward time travel is tangled in paradox and longing. Maybe it's forbidden. Maybe it's allowed but useless. Maybe it creates universes where you are a stranger. None of these paths lead to the simple wish you hold, to undo pain, to reclaim lost moments, to rewrite your life. And yet, the idea persists. Movies, books, and stories return to it again and again because it touches something universal. To go back is the dream of every broken heart, every grieving soul, every human being who ever whispered, if only. Let me ask you something. If you had the chance, would you truly change the past? Or would you, deep down, fear the ripple it would cause? That one word unsaid, that one step not taken, change it, and everything else changes too. The people you love now, the lessons you carry now, the very person you are now, gone, replaced by another timeline where you never arrived here, listening to this story. The truth is, the past shapes us, even in its pain. To erase it is to erase the journey that brought you here. Perhaps the universe resists backward time travel not because it is impossible, but because it is unwise. Because time is not meant to be edited, it is meant to be lived. And yet the paradoxes invite deeper questions. If the past is locked, if traveling backward is impossible or dangerous, does that mean time itself is a single road? Or are there infinite branches waiting, like pages of a book we haven't turned yet? That question leads us to the next chapter. Because to solve the paradox of going backward, scientists and dreamers alike began to imagine something even stranger. The idea that we live not in one timeline, but in many. Section 8 complete, 60 words. Tone. Section 9, multiverse and alternate timelines. If the past cannot be undone without paradox, then maybe the solution is simpler or stranger. Maybe the universe doesn't stop you from changing things. Maybe it just creates another version of reality where your changes exist. This is the idea of the multiverse, and it has become one of the most captivating possibilities for time travel. Think of every decision you've ever made, the clothes you wore today, the moment you said yes instead of no, the path you chose on your way home. Each choice feels small, but what if each one branched off into another world? A place where you picked differently, lived differently, became someone else entirely. This is not just fantasy. In quantum physics, there is an interpretation called the many worlds theory. It suggests that every possible outcome of a quantum event happens, not in one reality, but in many. When you flip a coin, in one world it lands heads, in another, tails. When you choose to turn left, in another universe you turned right. When you live through heartbreak, in another version of existence, maybe you found lasting love. And here's where time travel enters the picture. If wormholes or other exotic tricks allow us to step into the past, maybe we wouldn't rewrite our own timeline at all. Instead, we'd slip sideways into another branch, another universe where history unfolded differently. In that reality, you could meet a younger version of yourself and not risk erasing who you are. Because that self belongs to that timeline, not yours. On paper, it solves the paradoxes. No grandfather paradox. No collapsing loops, just infinite universes branching endlessly, every possibility played out somewhere. But emotionally, what does this mean for you? Imagine stepping through a portal and finding yourself in a version of Earth where one decision changed history. Maybe the Cold War never ended. Maybe electricity was never discovered. Maybe dinosaurs still walk the land. Or perhaps it's personal. Perhaps you find the version of yourself who pursued the dream you abandoned, who loved the person you walked away from, who lived a life you sometimes imagine late at night. Would you envy them? Would you pity them? Would you try to stay? Here's the haunting part. If every possibility exists, then you are not unique. There are endless versions of you, each shaped by 1,000 tiny choices. In one universe, you are listening to this story. In another, you turned it off. In another, you never found it. Time travel in the multiverse doesn't just stretch your imagination, it stretches your sense of self. This idea has crept into science fiction again and again because it is irresistible. It is hopeful. You might never lose anything forever because somewhere, in some branch, it still exists. But it is also unsettling. If everything exists, then what is the meaning of your choices? Does it matter what you do if another version of you is always doing the opposite? Physicists wrestle with this as much as philosophers do. Some argue the many worlds theory is the only way to make sense of quantum mechanics without paradoxes. Others insist it is untestable, that we may never be able to prove or disprove its existence. But emotionally, the idea clings to us because it speaks to something deep, our longing for second chances. Think about your own regrets. What if there truly is a world where you didn't make that mistake? Where you followed your heart instead of your fear? Where you took the risk you were too afraid to take? To know that such a place exists, even if you can never reach it, is both a comfort and a curse. Time travel into alternate timelines gives us freedom, but it also gives us distance. You could step into another universe, but you would never truly be home. Your past would remain unchanged. The loved one you lost here would still be gone, even if another version of them lives somewhere else. The comfort would be real, but the ache would remain. And yet, the multiverse sparks hope. It means the universe may be larger, stranger, and more forgiving than we ever imagined. It means that when we dream of what if, we're not only indulging fantasy, we might be glimpsing a truth hidden just out of reach. This is why the multiverse is not just science, it's an emotional lifeline. It reassures us that endings are never absolute, that choices are never final, that time itself may hold more doors than we see. And in that sense, even if we never build a machine to cross into another branch, the multiverse already changes us. It reminds us that we are not trapped, but connected to infinite possibilities. Still, we are left with a question. If alternate timelines exist, how do we find them? Is there a way to step across, or are they forever sealed? That's where science turns experimental. That's where equations meet laboratories. That's where we stop dreaming and start testing. Because time travel is not only a question of imagination, it is a question of evidence. And to understand whether our dreams can become reality, we must look at the experiments that already bend time in small but measurable ways. Up until now, much of our journey has been built on imagination, theory, and the mathematics of relativity. But you may be wondering, has anyone ever proven time travel even in the smallest way? Has science actually bent the clock not just on paper but in reality? The surprising answer is yes, and the evidence is hiding in plain sight. Let's begin with airplanes. In 1971, two physicists, Hafele and Keating, set out to test Einstein's predictions about time dilation. They carried atomic clocks aboard commercial flights, one eastward around the Earth, one westward, and compared them to identical clocks that stayed on the ground. When the planes returned, the results were stunning. The airborne clocks showed different times than the ground clocks, just as relativity predicted. They had, in effect, traveled slightly into the future. The difference was tiny, a few billionths of a second. But it was real. Time itself had shifted. The passengers on those flights, without ever knowing it, had moved a fraction forward relative to the rest of us. It wasn't science fiction. It was a ticketed flight, a boarding pass, a seatbelt, and a journey through time. And this effect doesn't just happen in experiments. It happens every day in ways that touch your life. The GPS system in your phone relies on satellites orbiting Earth. Those satellites experience both special relativity because they're moving quickly and general relativity because they are farther from Earth's gravity. Left uncorrected, their clocks would drift by about 38 microseconds per day. That doesn't sound like much, but it would throw GPS accuracy off by kilometers in a single day. So engineers constantly adjust the satellite clocks, essentially correcting for time travel effects. Every time you check your location, you are using relativity, using real evidence that time can bend. Then there are particle accelerators where we see time dilation in the most dramatic way. Subatomic particles called muons normally decay in a tiny fraction of a second. But when they are accelerated near the speed of light, their clocks slow down. Instead of vanishing quickly, they live many times longer than they should. In our world, seconds stretch into eternity for them. Scientists have measured this again and again, and the results are undeniable. At high speeds, time itself slows down, and it goes deeper still. In 2010, researchers at the National Institute of Standards and Technology, NIST, in Colorado placed two ultra-precise atomic clocks just 33 centimeters apart, one slightly higher than the other. The clock closer to Earth's gravity ticked more slowly. The difference was unbelievably small, but measurable. This proved Einstein right again. Gravity bends time even over less than a meter. Imagine that. Standing on a step stool makes you age infinitesimally faster than your feet below. What does all this mean? It means time travel isn't just theory. It's happening right now. Every astronaut on the International Space Station ages a little more slowly than you do on Earth. Every GPS satellite is living in a different rhythm of time than we are. Every high-energy particle zipping through the universe is experiencing a world where seconds are stretched. Of course, these are tiny steps. We're not talking about leaping centuries into the future or shaking hands with your ancestors, but they prove the foundation. They prove time is flexible, not fixed. They prove that the universe already contains the seeds of time travel. We are just learning how to notice them. And here is where the emotional weight sinks in. You don't need to wait for a wormhole to be discovered to realize you are already living in a time-bending universe. Every breath you take, every second that passes is relative. Your clock is not the same as anyone else's. No two people experience time in precisely the same way. You are already, in a sense, a traveler. But these experiments also whisper something humbling. Yes, we can measure the bending of time. Yes, we can stretch seconds and prove Einstein right. But so far, it's always forward, always into the future, always one way. We cannot use these tricks to rewind the tape, to step back into yesterday. The arrow of time still points forward, stubborn and silent. And so, we are left with both wonder and frustration. Wonder because the universe is stranger than we ever dreamed. Frustration because even as we prove time's flexibility, the door backward remains locked. But perhaps that frustration is the fuel. Every measurement, every clock, every satellite and particle accelerator tells us time is not absolute. Time is a landscape, and landscapes can be explored. Somewhere in these experiments may lie the first clue to something greater, a key that opens doors we haven't yet imagined. And that leads us to a new frontier. If physics shows us that time can bend, stretch, and shift, then why is it always forward? Why do we never see the tape play backward in the laboratory? The answer may lie in something even more mysterious, the nature of time's arrow itself. Because to understand whether we can travel backward, we must first ask, why does time flow at all? We've now seen how experiments, from satellites to subatomic particles, prove that time is flexible. It can stretch, it can bend, and it can flow at different speeds depending on where you stand in the universe. But here's the puzzle that grips every physicist, every philosopher, and maybe you too, right now. Why does time only flow in one direction? Why does the arrow always point forward? Think about your own life. You remember yesterday, but not tomorrow. You can watch a glass fall and shatter into 1,000 pieces, but never see those shards leap back into a perfect, unbroken form. You grow older, but never younger. Memories pile up behind you like footprints in sand, but ahead there is only mystery. Why? What gives time this one-way rule? The answer may lie in something as ordinary and as profound as entropy. Entropy is the measure of disorder in the universe. Imagine a tidy room. It takes effort to keep it neat. But if you stop, dust gathers, clothes scatter, chaos creeps in. Disorder increases naturally. That's entropy. And the laws of physics suggest that entropy always tends to rise. This is the arrow of time. The universe prefers disorder, and that preference creates direction. You can mix cream into coffee, but you can't unmix it. You can scramble an egg, but you can't unscramble it. Every moment, energy spreads out, systems move from order to chaos, and time marches forward. But here's the astonishing part. The equations of physics themselves don't demand this one-way rule. At the deepest mathematical level, the laws of motion are reversible. If you filmed the movement of particles and ran the footage backward, the math would still make sense. So why, in practice, do we never see rivers flow upstream or people grow younger? It comes back to beginnings. At the birth of our universe, the Big Bang, entropy was astonishingly low. Everything was neat, ordered, compressed into a tiny blazing point. As the universe expanded, entropy rose. Stars formed, galaxies spun, planets cooled, and life emerged. Entropy kept increasing, giving us the arrow of time we feel in our bones. Without that strange, low entropy starting point, there would be no sense of past or future, no ticking clocks, no unfolding lives. Now pause and let that sink in. The reason you can remember your childhood but not your death, the reason history books tell of ancient empires but not future ones, the reason tears fall downward and not upward, all of it may trace back to the very first moment of creation. Your everyday experience of time may be a shadow of the universe's birth. And yet this explanation raises new mysteries. Why was the universe's entropy so low in the beginning? Why did it start in such an improbably ordered state? No one knows. Some physicists suspect it was a random fluke, a roll of cosmic dice. Others suggest deeper laws, hidden symmetries we don't yet understand. But there is another angle, one that connects science to something deeply human: memory. You see, your mind itself is bound to entropy. You remember the past because your brain records information in a way that increases disorder. Each new memory etches patterns into neurons, rearranges molecules, spreads energy. Recording the past aligns with the natural flow of entropy, but recording the future would require reversing that process, the undoing the chaos, rebuilding the order. It would go against the grain of the universe. In this way, the arrow of time is woven not just into stars and galaxies, but into your very thoughts. The way you remember, the way you dream, the way you live, all of it follows time's forward pull. You are a creature of entropy, carried along on its unstoppable current. And yet, even here, cracks appear. Some quantum experiments hint that at the smallest scales, the distinction between past and future blurs. In the quantum world, particles seem to exist in superpositions, as if the future is not yet decided, as if time itself is uncertain. In certain interpretations, events can even appear to influence the past. Could the arrow of time, so firm in your daily life, be nothing more than an illusion emerging from probabilities? That question lingers at the edge of science, unresolved, haunting. And it brings us to a strange possibility. If time's arrow is rooted in entropy and entropy depends on the universe's beginning, then perhaps, just perhaps, it could be different somewhere else. In another universe, in another cosmic cycle, maybe entropy flows the other way. Maybe there, beings remember the future and not the past. Maybe there, glasses reassemble, ashes turn into logs, and stars grow brighter instead of burning out. You cannot help but feel the wonder, can you? That the reason your life feels like a story with a beginning and an end might be nothing more than the shape of entropy itself. That the arrow of time could, under other conditions, point in reverse. But here, in our world, you are bound to forward motion. Your body ages, your memories form, your story unfolds. You can never walk back into yesterday. But here's the twist. Just because time flows forward doesn't mean you are powerless within it. You may not rewind the clock, but you can choose how to fill the moments as they come. You can give shape to the story entropy forces you to live. So the arrow of time is not just a law of physics, it is also a reminder that life is fragile, that moments are fleeting, that the forward flow is unstoppable. And maybe that is why it feels so precious. Because if you could live backward and forward at will, would you still treasure the sunrise? Would you still hold memories like jewels? Or is it precisely the one-way arrow, the unyielding march forward that makes each second shine? And yet, as firm as time's arrow seems, some daring scientists whisper, what if we could bend it? What if there were ways, through exotic physics, through hidden loopholes, to push back against entropy's rule? You've seen how the arrow of time points forward, driven by entropy, shaping your memories, your aging, your story. But what if that arrow isn't as absolute as it feels? What if, hidden within the laws of physics, there are loopholes, subtle cracks in the rules that might let you bend or even break time's one-way flow? Think of it this way. Every game has rules, but every game also has exceptions, shortcuts, or clever strategies that can change everything. The universe is no different. And for centuries, dreamers, philosophers, and scientists alike have asked the daring question, could there be a way to step off the straight road of time and explore other paths? One of the most famous loopholes lies in Einstein's own equations. You already know that massive objects bend space and stretch time, but under certain conditions, the bending can form closed loops, what physicists call closed time-like curves. Imagine space-time folding back on itself, so that by walking forward, you eventually return to your own past. In theory, such loops are allowed. The math works. The universe does not forbid them outright. But to create such loops, you'd need something exotic, something like a wormhole. Picture space-time as a sheet of paper. If you fold the paper, two distant points can touch. Punch a hole through, and you've made a shortcut. That's the wormhole, a tunnel through the fabric of reality. Step in one side, and you step out the other, possibly light years away. And if you accelerate one end of the wormhole, racing it near the speed of light and then bringing it back, the time difference between its mouths creates a potential time machine. Enter one side, and you could exit not just in another place, but in another time. The idea is dazzling, almost intoxicating. And yet, reality has a way of resisting such dreams. Wormholes, if they exist at all, would be unstable. They would collapse instantly unless held open by something called exotic matter. A form of energy with negative pressure, something we've never seen in nature. Without it, the tunnel slams shut. With it, who knows? Still, the possibility teases, because exotic matter isn't entirely outside imagination. Quantum physics hints at strange effects, negative energy densities, the Casimir effect, quantum fluctuations, that might, in theory, provide the stuff to stabilize a wormhole. For now, it is speculation, but speculation has a habit of becoming discovery. Another loophole comes from the quantum world itself. At scales unimaginably small, particles seem to cheat the rules of time. Some interpretations of quantum mechanics suggest that events can be influenced not only by the past, but also by the future. A particle doesn't simply decide what it is until measured, and that measurement might ripple backward as well as forward. To you, this may sound like science fiction, but experiments with entangled particles, pairs linked in ways that defy distance, hint that information might not respect time's arrow as rigidly as you do. And then there is the dream of cosmic strings. These are hypothetical defects in spacetime, remnants from the earliest moments of the universe. Imagine infinitely thin filaments stretching across the cosmos, each with immense mass and tension. If two strings passed close to each other, spacetime could twist so dramatically that closed time-like curves might form. In other words, a path into the past. Again, no experiment has confirmed their existence, but on paper, they fit. Of course, every loophole carries dangers. Time travel is not just a thrill ride, it's a paradox waiting to happen. You've heard the classic ones. If you went back and stopped your grandparents from meeting, how would you be born to travel in the first place? This is the infamous grandfather paradox. Or imagine meeting your past self and giving them advice. If they succeed because of your words, who gave you the knowledge? The loop feeds itself. Physicists wrestle with these paradoxes because if time travel is possible, they must be resolved. Some theories, like the many worlds interpretation, suggest a solution. Every time you travel back and change something, you create a new branch of reality. No paradox, just parallel timelines. Others argue for self-consistency, meaning the universe will always find a way to prevent contradictions. If you go back, you can act, but whatever you do was already woven into history. No matter how hard you try, you cannot change the past, only fulfill it. Either way, the loopholes tempt us. They whisper that maybe time is not a prison. Maybe somewhere in the fabric of reality there are cracks big enough to slip through. And yet, even as these ideas dazzle, they humble you. Because for every loophole imagined, the universe throws up walls. Exotic matter is theoretical. Wormholes are unstable. Quantum time tricks remain unproven. Cosmic strings, if real, lie far beyond our reach. It's as if nature has set the rules deliberately, giving you glimpses of possibility, but holding them just out of reach. Still, isn't that the story of science itself? Every great discovery begins as a loophole, an impossibility, a wild dream. Once, heavier than air flight was a fantasy. Once, splitting the atom was madness. Once, the idea of humans walking on the moon was absurd. And yet each one came true. So perhaps when you hear of wormholes or quantum time loops, the right response is not disbelief, but patience. The universe is old, our science is young. Who knows what centuries of curiosity may uncover? But here's the most haunting question. If loopholes exist, who or what might already be using them? If time can be bent, if wormholes can be stabilized, then the possibility of time travelers is real. Maybe not with glowing machines or silver suits, but hidden in ways you cannot detect. Could déjà vu, those strange feelings of familiarity, be echoes of timelines brushing against each other? Could stories of visions, precognition, and strange coincidences be shadows of time's loopholes at work? You cannot prove it, but you cannot dismiss it either. And so you are left here at the edge of science and wonder. The arrow of time seems firm. Entropy holds you in its grip, but cracks appear, loopholes whisper, and the future remains wide open. Which leads to the next great question. Even if you could travel in time, should you? What would it mean? Not for physics, but for humanity, for morality, for your own sense of meaning. So far, you've journeyed through physics, through wormholes, through entropy, through the mathematics that tease and tempt. But pause now and ask yourself, even if time travel were possible, even if you had the key in your hand, should you use it? This is where science meets philosophy, where equations meet conscience. Because time travel isn't just a question of can we, it's also a question of should we. Imagine holding such power. The ability to rewrite history, to undo tragedy, to relive joy, to reshape entire civilizations. At first, it sounds irresistible. Who wouldn't want to go back and prevent a war, save a loved one, or warn humanity of disasters before they happen? But every action in the past ripples forward. A small change can cascade into enormous consequences. This is the famous butterfly effect. Step on a butterfly a million years ago, and the course of evolution may veer into an entirely different world. Would you take that risk? Consider something even more personal. Suppose you could travel back and meet your younger self. You'd want to offer advice, comfort, maybe even warnings about mistakes. But here lies the paradox. By giving yourself knowledge you didn't earn at the time, you change who you are. You erase the journey that shaped you. Would you still be you if the struggles, heartbreaks, and lessons were erased? And now, think bigger. What if entire nations had access to time travel? Governments, corporations, militaries, do you trust them to use it wisely? Or would time itself become a battlefield, just rewritten again and again by those in power? History books would lose meaning. Reality itself could fracture. The weight of responsibility becomes staggering. This is why many scientists believe that if time travel is possible, it must also come with barriers, rules baked into physics itself that prevent abuse. Perhaps paradoxes are not just curiosities but safeguards. Perhaps the universe resists being rewritten, closing doors that humans should never open. But there is another way to see it. What if the ethics of time travel aren't about the past, but about the present? You may not be able to rewind or fast forward life, but you do have a choice about how you live in the time given. Every moment you decide how to treat others, how to act, how to speak. Those decisions ripple into the future, just as powerfully as any time traveler's actions might. In that sense, you are already shaping history, not with machines, but with choices. This perspective is humbling because it suggests that the real ethical challenge is not in possessing a time machine, but in realizing that you already influence tomorrow with every step you take today. You don't need to leap centuries to leave a mark. You are already doing it. Still, let's return to the thought experiment. Suppose time travel does exist. Would you use it to erase pain? Or would you accept pain as part of the human story? Would you rewrite tragedy? Or would you see meaning in the lessons it leaves behind? These are not scientific questions. They are human questions. And here's the haunting truth. The desire to control time is as old as humanity itself. From myths of gods who turn back the sun to legends of fountains of youth to religions promising eternal life, humans have always fought against the arrow of time. We long for more days, more chances, more control. Time travel, in many ways, is the ultimate expression of that longing. But maybe, just maybe, the wisdom lies not in breaking time, but in embracing it. Knowing that every moment is unrepeatable makes it precious. Knowing that the past cannot be rewritten makes memory sacred. Knowing that the future cannot be seen makes hope powerful. If you could live forever or replay every choice, would life still hold the same intensity? Or is it the very limit of time, the ticking clock, that gives meaning to existence? This is the paradox of ethics and time. The very power we dream of may undermine the value we hold most dear. If nothing can be lost, can anything truly be loved? Yet you can't help but wonder, what if somewhere out there beings more advanced than us have already solved this puzzle? What if they do walk the timelines, slipping through eras like pages in a book? Would they interfere? Would they help us? Or would they stand back, knowing that every civilization must face its own test of time? It is a question you may never answer, but perhaps the point is not to answer it. Perhaps the point is to recognize that time travel forces you to confront your deepest values. What do you cherish? What would you risk? What are you willing to change? And what must remain sacred? In the end, the ethics of time travel are not about machines. They are about humanity. They are about you. Because time travel isn't only a scientific dream, it's a mirror reflecting what you believe about life itself. And so you arrive at a deeper truth. Maybe you don't need a time machine to honor time. Maybe the real challenge is to live fully in the arrow you've been given, forward, moment by moment, choice by choice. But the story doesn't end here. There is still one last mystery to explore. If time travel changes not just science and ethics, but meaning itself, then what is time, truly? Not the clocks, not the arrows, not the equations, the essence, the fabric, the heartbeat of the universe. Memories, regrets, and dreams. 1,000 to 1,100 words. If you could step through a doorway and relive just one moment of your life, which would it be? Would you go back to the warmth of your childhood, running barefoot through the streets of your hometown when everything felt infinite and safe? Or maybe you'd return to a moment of regret, that one choice you wish you could rewrite, the word you never said, the opportunity you let slip by. Time travel, for all its scientific theories and dazzling physics, is at its core a deeply human desire. It's about memory. It's about longing. It's about the fragile heartbeat of existence. As you listen now, you probably feel that strange pull within you. We all do. The past is never really gone. It lingers in photographs, like in the smell of old books, in the sound of a song that instantly transports you to another year. It's almost like we already possess a natural form of time travel, memory. Close your eyes and you can travel decades in an instant. No machine required. Yet as powerful as memory is, it's imperfect. It blurs, it fades, it plays tricks. And so humanity dreams of something greater, a way not only to remember, but to return. This is why the idea of time travel strikes so deeply. Because it isn't about science alone, it's about healing. Imagine a grieving mother stepping back in time just to hold her child one more time. Imagine a veteran returning to the battlefield, not to fight, but to choose peace instead. Imagine yourself revisiting the single best day of your life, not as a fading memory, but as a living reality. The thought alone fills your chest with a mix of wonder and aching. But here comes the paradox. If you could change your regrets, would you still be you? Think of the choices you've made, even the painful ones, as stones in a river. Remove one stone, and the current changes forever. Maybe that heartbreak you endured shaped the strength you carry now. Maybe the job you lost led you to the opportunity that truly mattered. The temptation of rewriting history often blinds us to the truth. Sometimes our scars are what define us. That's why many philosophers argue that time travel is not about fixing the past, but about understanding it. It's not about changing the story, but about finally seeing it clearly. When you revisit your own memories, when you let yourself sit with the pain, the joy, the confusion, you are, in a sense, traveling through time already. Not with machines, not with wormholes, but with the heart. And then, of course, there is the other direction, the future. What would you give to know what lies ahead? To peek at the next chapter of your life? To see if your dreams come true, if your hard work pays off, if the person you love will still be by your side? The future calls to us just as strongly as the past does, because it represents both promise and fear. The unknown is the greatest frontier of all. Science, with all its brilliance, may one day unlock the doorway to that frontier. But even if it never does, you already hold the ability to shape tomorrow. Every choice you make today is a form of time travel. The decision to forgive, to work harder, to speak kindly, each of these ripples forward into the future, altering what has not yet happened. That is the paradox of being human. You cannot visit the future, but you can create it. So pause for a moment and breathe. Think of the memories you carry, the ones you treasure and the ones you wish you could rewrite. They are yours. They are your private form of time travel. Think of the dreams you hold, glowing faintly on the horizon. They are invitations to step into tomorrow. You are already walking through time, one fragile, beautiful second after another. And maybe, just maybe, this is the ultimate truth. We don't need machines to travel through time. We need awareness. We need gratitude. We need to recognize the miracle that every heartbeat is carrying us through the greatest journey imaginable, from birth to death, from possibility to memory. Time is not an enemy to conquer. It is the companion that walks with us, shaping every smile, every tear, every breath. As you let this sink in, consider this thought. If you had a time machine right now, would you rush to use it? Or would you pause and realize that the present moment, this exact second, is itself a miracle of time? Maybe the greatest form of time travel is not going backward or forward. Maybe it is learning to be fully alive in the now. This is the human side of time travel. Not equations, not paradoxes, but memory, regret, healing, and hope. And as you carry this thought, we prepare to step into our final chapter, where we ask the most haunting question of all.